Did you know that over 90% of the universe is made up of matter we cannot see or fully explain? Why is it that we can download high-resolution images from the red planet online in minutes, but crucial data from a mysterious interstellar visitor has been missing for 45 days? On November 13th, while the world was abuzz with excitement over NASA's latest batch of Mars images, a more disturbing and thought-provoking question suddenly emerged. If they could transmit data from Mars so quickly, what happened to the 3I Atlas images taken on October 2nd? Those images are still missing, 45 days later. The missing images were taken by HiRISE, the highest resolution camera ever orbiting Mars, operated by a team from the University of Arizona. With current processing power, the data should have been released long ago. The strange delay not only intrigues the public, but also raises serious questions. Is something being deliberately delayed or kept secret? When asked about the credibility of NASA management's explanation for the delay, their overall response was calm, neither denying nor affirming. The reason given was that NASA was only providing information based on what it had, and stakeholders could only rely on the same data source. However, the need to find out the truth was still emphasized, along with the expectation that more details would be released in the coming days. While NASA does not intentionally withhold information, operating within a slow bureaucratic system can create mixed public perceptions. Many believe there are layers of information that have not been revealed, adding to public curiosity. One point that has caught the attention of many is the significant time gap between the October 2nd photo and the November 13th release. While the technical analysis continues, scientific attention is turning sharply back to the interstellar object 3I Atlas, which has undergone a sudden and inexplicable transformation that has the astronomical community on edge. In the latest set of observations, 3I Atlas has suddenly accelerated into a sharp and distinct dust tail, changing dramatically in just a few weeks, faster than any existing model predicted. Once a barely perceptible speck in the sky, it has become active and prominent, forcing research teams to reconsider basic assumptions about the dynamics of extrasolar objects. At about the same time, radio astronomy networks reported recording a short, unverified radio burst at about 1,420 megahertz, which coincides with the hydrogen line of a neutral hydrogen atom. This is a preferred frequency range for deep space surveys and is particularly sensitive to those looking for extraterrestrial signals. Although there has been no independent confirmation, the coincidence with Atlas's increased activity phase has scientists scrutinizing every bit of data. And as usual, the information gap has sparked curiosity, leading to bold hypotheses ranging from physical reactions not described by standard models to conspiracy mongering, all of which are still speculative and lacking evidence. The situation is still changing by the day, and every new data is being closely monitored by research teams as 3I Atlas continues to show itself to be one of the most mysterious interstellar objects ever to pass through the solar system. 3I Atlas is the third interstellar object confirmed to enter the solar system and has been a priority observation target for many telescopes around the world since its discovery a few months ago. Initially, it followed predicted models almost perfectly: faint, slow-moving, featureless, looking like a cold, icy remnant from a distant star system drifting quietly into the inner solar system. But new developments in recent weeks have forced researchers to reconsider every assumption. Atlas's activity curve has begun to challenge current understanding of how interstellar ice reacts to sunlight, revealing a series of unusual changes that current physical models cannot fully explain. The first sign that something was amiss with 3I Atlas came when telescopes spotted a column of material pointing almost directly at the sun, in stark contrast to the typical comet tail. Instead of being blown away by radiation pressure and solar wind, the material seemed to be being ejected in the opposite direction than expected, creating an asymmetric, truncated, and unbalanced structure that puzzled observers. It was a rare exception to standard comet behavior, which typically produces two separate tails, a dust tail and an ion tail, pushed in different directions by standard radiation forces. 3I Atlas, on the other hand, creates a dense, straight, and steady stream of gas that appears to be growing back toward the light source. Preliminary models suggest that the material may be escaping from a local vent or a deep fissure in the comet's core, confining the gas flow and keeping it in a very narrow direction. However, the exact mechanism that causes this stream to reverse its normal course remains completely unknown. Remarkably, the strange gas structure has remained virtually unchanged over many observation periods, not expanding noticeably, not fading significantly, but remaining as a fixed stream of emission, seemingly separate from the dynamic variations of the comet as a whole. It is this unusual stability that makes 3I Atlas increasingly a big puzzle for researchers. Is this simply the result of a peculiar outgassing phenomenon related to the structure of the surface and interior of the comet, or is it revealing a physical mechanism never before recorded in interstellar objects? As scientific teams continue to analyze data from the latest series of observations, the astronomical community is starting to become more bold in its speculation, and the level of curiosity about 3I Atlas is being pushed to a new level where all scenarios, from purely technical to the potential to shake current models of cosmology, are forced to be considered. In a moment that left observers almost stunned, 3I Atlas's entire structure suddenly transformed. New data from large aperture telescopes in the southern hemisphere, particularly observatories in Chile and South Africa, showed that the jet stream that had once been directed toward the sun had completely reorganized, transforming into a long, well-defined cometary tail that stretched away from the light source, just as classical dynamical models would have predicted. From a truncated retrograde column of material, 3I Atlas suddenly took on a more familiar shape, as if its entire jet system had been reset from scratch. What stunned astronomers was not just the sudden change in shape, but also the speed of the phase transition, forcing many experts to immediately review all observational data. In such a short period of time, the structure of the object changed so drastically that it looked as if some force had ripped or pulled material out of the comet's core. For a celestial body moving in the interstellar medium, where physical processes are usually slow, steady, and relatively predictable, this level of change was considered a rare anomaly, prompting 3I Atlas to be immediately placed on special monitoring, with each new frame of data carefully re-examined. Almost simultaneously with the change in shape, initial physical analysis further enigmaticated 3I Atlas. Photometric and spectroscopic data showed that the dust ejected by the object was not the familiar micron-sized ultrafine particles found in solar system comets, but rather unusually large particles, about 1/10 of a millimeter. For interstellar dust, this is enormous, as particles are typically very small, light, and difficult to exist in large quantities. Yet 3I Atlas was consistently ejecting these heavy particles at speeds of just a few meters per second. Even more puzzling is the complete lack of impact or thermal flares, which are typically seen when ice on a comet's surface sublimates suddenly. Instead of chaotic outbursts, Atlas shows a slow, orderly, almost purposeful eruption pattern. This suggests that its core may not be a loose mass of ice like a typical comet, but rather a denser, more cohesive structure, perhaps even composed of multiple layers, each of which reacts differently to sunlight. These features have led researchers to question whether 3I Atlas is just a strange ice mass from a distant star system, or whether it is revealing an entirely new physical mechanism not previously documented in the solar system. Each new piece of data collected both expands scientific understanding and adds to the mystery surrounding this interstellar object. Adding to the puzzle, spectroscopic measurements revealed that 3I Atlas's sublimation began as early as 3.5 astronomical units from the sun. At that distance, temperatures are too low for any form of water ice to vaporize, and only supervolatile substances like carbon monoxide or carbon dioxide are sensitive enough to undergo phase transitions at such cold conditions. The early and vigorous appearance of these molecules suggests that 3I Atlas possesses an extremely rich source of volatiles, reminiscent of materials formed at the outer edges of a star system, where temperatures can hover near absolute zero for billions of years. It's the kind of icy environment that exists at the edges of star systems, similar to the Oort belt or the Kuiper belt in our solar system. But the data points to one crucial detail. 3I Atlas doesn't belong to any of those populations. Its chemical composition, orbit, and activity levels all point to an origin outside any known model of the solar system. It came from somewhere else, much farther away, beyond the reach of direct human observation, from a region of space where our familiar rules may no longer be an accurate template. When it comes to reported radio signals, the mystery surrounding 3I Atlas continues to grow. Unusual features like a jet of material that once headed toward the sun and an expanding dust tail behind it were enough to get the research community's attention. But that interest took a new turn when it was reported that radio observation networks had detected a strange pulsing pattern near the hydrogen line at 1,420 megahertz. This is no random frequency. In radio astronomy, 1,420 megahertz is one of the quietest and least noisy bands, making it ideal for high-precision measurements. More importantly, this frequency has long been chosen by programs searching for extraterrestrial intelligence as a potential reference channel for any civilization that might actively broadcast a signal. It is symbolic, like a universal coordinate that any intelligence in the universe would recognize. The coincidence of 3I Atlas's unusual activity and the appearance of a radio pulse pattern in a frequency band considered sacred in the search for extraterrestrial intelligence has many scientists, even the most skeptical, keeping an eye on every new bit of data. They can't confirm anything, but they can't ignore it either, because in science, anomalies are rarely just anomalies. They often open doors to discoveries that have never been fully understood, or to truths that humanity may not yet be fully prepared to face. The reported radio pulse lasted only a few moments and was recorded by only a handful of independent observation teams. To date, none of the data sets have been verified by the scientific community, and it is likely to be technical noise, a leak from Earth, or an unrelated natural phenomenon. However, the pulse's appearance during the active phase of Atlas 3I has forced several radio observatories to expand their monitoring range, scanning the corresponding area of the sky for repeats, which are the only key to tracing the signal's source. There is no evidence yet that 3I Atlas is the source of the radio emissions. However, telescopes are sticking to the 1,420 megahertz frequency, because even a single signal can sometimes open up entirely new avenues of research. This is all the more remarkable because comets rarely emit radiation outside of familiar molecular lines. Any deviation from the standard model could be scientifically significant, or at least enough to keep the research community on alert and on the lookout. Meanwhile, 3I Atlas itself continues to change at a staggering rate. The comet's tail is growing longer, and its shape and brightness are changing constantly, suggesting that the comet's nucleus may contain multiple independent active regions. These observations provide a rare opportunity to directly study how an icy interstellar object reacts as it begins to heat up during its approach to the sun. Atlas may develop a thicker dust shell, fracture its surface, and create new dust bands, all of which are key to deciphering its internal structure and evolutionary history. Compared to two previously observed interstellar objects, the highly unusual Oumuamua and the relatively typical Comet 2I/Borisov, 3I Atlas exhibits significant differences. It possesses a large dust mass, a rapid rate of change, and unique gas behavior that has never been documented. These characteristics make 3I Atlas one of the most important interstellar objects ever discovered, opening the door to a better understanding of how matter is formed and processed in distant star systems. Scientists are scrambling to gather data, as it's possible 3I Atlas could break apart as it approaches the sun. If that happens, the original structure could be completely destroyed, but the deepest layers of material inside the remnant, which have been wandering among the stars for millions of years, could be exposed. This would give humanity a rare opportunity to directly study the composition of a piece of material from another world, where the physical and chemical conditions may be very different from those of our solar system. Today, observatories on multiple continents are collaborating to keep a close eye on 3I Atlas. Optical telescopes record variations in brightness and tail shape. Infrared instruments pinpoint the hot regions where sublimation is most intense. Spectroscopic measurements trace the supervolatile molecules that characterize the interstellar medium. In parallel, radio telescopes hunt for rare molecular lines and any unusual emissions that coincide with periods of increased activity, building up a rare radio archive for an interstellar comet. When all the data sources are combined, the teams hope to build the most detailed profile ever of an interstellar object, surpassing even the current understanding of 2I/Borisov. If Oumuamua is the open question and Borisov is the benchmark, 3I Atlas could be the key to painting a fuller picture of the diversity of extrasolar bodies. The growing amount of data will allow for reconstructions of Atlas's ejection of dust and gas over time, inferring its rotation period, the locations of active regions, and the structure at the star's apogee, where ejecta interacts directly with radiation in the solar wind. Even small fluctuations in the light curve could reveal whether the comet's nucleus is elongating, becoming asymmetrical, or starting to break up. These observations are especially important because 3I Atlas represents a class of objects that have been ejected from their parent star systems and wandered through the galaxy for millions of years. Along the way, their surfaces have been eroded, their compositions altered, and their interiors reshaped by countless small collisions. Upon entering a new star system, the thermal shock from the strange radiation could trigger cometary behavior unusual by solar system standards, creating a natural laboratory for studying the evolutionary history of icy matter on a galactic scale. The scientific community is therefore watching 3I Atlas with unusual intensity. Whether the reported radio pulses are actually real signals or just glitches, the array of phenomena Atlas is exhibiting is astonishing enough. An unusually accelerating dust tail, large and heavy dust grains rarely seen in the interstellar medium, and an active layer of volatile material very early on at such a distance from the Sun. All of this suggests that the object possesses an incredibly complex layered structure, formed under conditions that are not fully captured by current models. This raises an inescapable question. Why would an object that is supposed to be the result of chaotic and random processes exhibit such organized complexity? Given that the jet was once a stable jet heading straight for the Sun before collapsing and transforming into a typical comet tail, it is hard to ignore the possibility that this phenomenon is more than just natural venting. The existence of a jet that remains stable and cohesive over significant distances in a fluid dynamic environment requires a special exhaust geometry or a nozzle-like structure. From there, more daring hypotheses emerge, though there is still no direct evidence. If 3I Atlas is a piece of planetary crust, or even part of a giant Dyson-like technological structure in theoretical models, then the complex layered structure we see could be the result of an artificial process, or at least a type of geological processing that comets don't normally undergo. The presence of heavy, slow-moving, relatively homogeneous dust grains further raises the possibility of a controlled ejection mechanism or a low-gravity environment with minimal escape velocity. Whatever the final solution, Atlas is not just a cold physics problem, but a cosmic detective case where each new piece of data is a tricky clue. In the coming weeks, as 3I Atlas approaches the Sun, most experts expect its rate of change to accelerate. New jets may erupt from fresh cracks in its surface, tail structures may shift, branch, or break off, and unexpected patterns of radiation from infrared to radio may appear. For scientists, this is a rare golden opportunity to observe an interstellar object at its most active. But in the context of increasingly fierce competition between superpowers in space, 3I Atlas has taken on another layer of significance. Any strange signals or unusual behavior from the object could quickly become fodder for strategic speculation. Some commentators in the United States have questioned whether any countries are secretly monitoring Atlas more closely than they are publicly admitting, or are seeking to exploit the data before their rivals. Some argue that if 3I Atlas were to produce a repeating signal, even if it were entirely natural, intelligence agencies could still view it as having strategic value. History shows that any unusual phenomenon in space is susceptible to competitive interpretation, especially when it touches on the security interests or technological ambitions of major powers. More skeptical observers also note that if Atlas suddenly changed orbit due to a major outgassing event, countries could see it as a natural test of their early warning systems. In a world where the militarization of space is on the rise, no signal is too small to ignore. And as an unintended consequence, 3I Atlas has become a focal point between pure science and geopolitics, where every measurement, every signal pulse is both research data and a sensitive detail in a chessboard much larger than the icy object itself hurtling through the solar system. But beyond all the theories, what matters most is the scientific truth. Before us is a tiny ancient traveler from a distant star system, revealing its past in real time. Every new image, every spectroscopic measurement, every tiny change in the star's crust brings humanity closer to understanding the universe through the journey of a piece of matter that has wandered between the stars for millions of years. 3I Atlas is both a mystery and a gift that science has rarely had a chance to touch. Each change it reveals could be part of a much larger story. The story of the origin of matter in the galaxy, the star systems it formed from, and our place in the vast cosmic structure. Atlas is not just traveling through the solar system. It is opening a window for humanity to look deeper into its own past. Here's the lesson I want you to take away from this. Science isn't about fitting new data into old boxes. It's about having the courage to build new boxes when the data demand it. We must remain open to the impossible until it's proven wrong. What do you think is going on with 3I Atlas? Is it just a strange rock or a messenger from the distant past? Leave your theories in the comments below, and if you want to stay up to date on these interstellar mysteries, be sure to subscribe and turn on notifications. Don't miss the latest data on this historic moment in the universe.